The the current design, so the version 3 of Optimus, I think is the right design to go to volume production, but it is a significant redesign from version 2. In fact, almost nothing stays the same.
The new face is now equipped with an LED screen with brightness over 600 nits, providing clear visibility even under strong lighting. With a dedicated processor, the robot can respond with emotional expressions in just 80 milliseconds. So, what does Tesla aim to achieve with this facial upgrade? What changes did Tesla make to the robot's face in Gen V3? In the third generation of the Tesla bot, the face has undergone a significant design revolution to better fulfill the robot's role in living and working environments alongside humans. In previous versions, Optimus's face was merely a smooth plastic mask with no expression, symbolizing a purely mechanical being. However, in Genesis 3, the front of the robot has been completely redesigned, incorporating elements of technology, aesthetics, and applied psychology. The first and most important change lies in the material used for the face. Instead of using hard plastic or other easily manufactured materials that lack flexibility and cannot display information, Tesla has switched to a high-resolution LED screen. This is a strategic leap forward, as the LED display not only enables facial expressions such as blinking, raised eyebrows, or emotional states like happiness, confusion, and attentive listening, but also functions as a visual communication gateway between the robot and humans. The use of an LED screen also allows for periodic software updates to improve facial expressiveness, rather than being limited by a static physical structure as before. Very few humanoid robots on the market today can achieve this. Boston Dynamics and Agility Robotics, for example, still don't equip their robots with facial displays, instead relying on audio systems or simple signal lights. Meanwhile, Tesla has chosen to turn the robot's face into an active communication tool, reducing the mechanical impression and enhancing user experience through a more human-friendly design. Besides the material, the change in color is also a noteworthy update. Previously, the Tesla bot's face had a uniform black or gray color that didn't reflect light, acting merely as a backdrop for the head. In the Gen 3 version, the front is coated with a subtle reflective paint that creates a soft lighting effect, making the face easier to see in various environments, from natural daylight to indoor or dimly lit settings. This paint was selected not only for its visual appeal but also to help highlight expressions displayed on the LED screen, preventing the light from being swallowed by the dark surface as in earlier versions. In the robotics industry, fine-tuning paint color is not a trivial matter. It plays a key role in how robots are perceived, especially in contexts involving children, the elderly, or people unfamiliar with automated devices. A bright, clear, and friendly-looking face can ease apprehension and foster a sense of safety. Ultimately, the most valuable aspect of the face redesign is the robot's ability to display real-time expressions. In the past, Optimus was incapable of showing any emotional state. Its face was a lifeless surface. But in Genesis 3, thanks to integrated AI within the central control system and natural language processing algorithms, Tesla bot's face can respond immediately to specific situations. For example, when a voice command is received, the screen shows a listening status with wide-open eyes. Once the task is completed, it displays "done" with a calm expression. And in the case of an error, the face may show a confused or apologetic look, closely mimicking human behavior. This marks a major advancement compared to today's rigid robots, as the ability to convey emotions not only makes the robot easier to interact with, but also enhances efficiency in environments like elderly care, customer service, education, or collaborative teamwork. Beyond expressing emotions, the face of Optimus Gen 3 also integrates multiple sensors, such as high-resolution cameras, light sensors, and directional microphones, allowing the robot to see and hear with accuracy. These sensors are cleverly hidden beneath the LED surface, resulting in a seamless, smooth design with no exposed mechanical components. This brings two clear advantages. First, it enhances the robot's aesthetic appeal, and second, it protects the hardware from dust and minor impacts, which is especially crucial when the robot operates in crowded or public spaces. Another notable point is that Tesla's facial design choices are not random. They are based on numerous psychological studies of human reactions to robots. Elon Musk has stated that a robot doesn't need to look exactly like a human, but it must appear soulful enough to avoid feelings of unease or fear. This explains why Tesla did not opt for hyper-realistic human-like facial features, but instead chose to convey emotion through symbols and light. This approach helps the robot avoid falling into the uncanny valley, a phenomenon where human-like robots cause discomfort due to subtle imperfections. Instead, Optimus face design strikes a balance: modern, technological, yet approachable and user-friendly. Once again, please help us reach 15,000 subscribers. This is important for us to stay motivated. Thank you. What has Tesla changed in the facial material of Optimus Gen 3? One of the most symbolic changes on the Tesla bot Gen 3 doesn't lie in its arms or legs, but in its face. From a rigid, expressionless plastic surface, Optimus's face has now been entirely replaced by a refined LED screen, marking a breakthrough in how humanoid robots interact with humans. This is not merely an aesthetic decision. The shift in material reflects Elon Musk's deeper strategic vision of turning Tesla bot into a communicative entity, flexible enough to work, yet friendly enough for humans to want to collaborate with. In the real world, where emotions and nonverbal cues play a crucial role, a robot capable of expressing facial emotions represents a revolutionary difference. Using an LED screen for the face brings significant benefits that hard plastic simply can't offer. First and foremost, it enables Tesla bot to display a range of facial expressions, from focused eyes and a gentle smile to processing states or even skeptical looks. Signals that help users understand the robot's current state and response in real time. In work or home environments, this removes ambiguity in communication and creates an emotional bridge between humans and machines. No longer just a cold, command-executing entity, Optimus can become a friendly partner, capable of responding through facial expressions, something humans naturally expect from humanoid AI. The material change also opens up the ability to display information directly on the robot's face. Instead of requiring a secondary screen for status updates, error notifications, or instructions, the LED face can now fulfill this role more naturally and effectively. For instance, while working in a factory, Optimus's face could show a processing status or display a simple warning symbol if an error is detected. In service environments, the robot can use its face to greet customers, guide users, or indicate states such as receiving command or please wait. Seemingly simple cues that are actually vital in everyday communication. From a technical perspective, transitioning from plastic to LED also reflects Tesla's increasing optimization in hardware-software integration. For the LED face to operate smoothly and express emotions quickly and accurately, the AI's graphic processing system must be powerful and stable. This showcases Tesla's concurrent advancement in hardware and software, deep learning models, behavior recognition, context-aware responses. Additionally, using an LED surface allows Tesla to reduce the weight of the head compared to incorporating multiple mechanical parts like cameras or 3D expression modules. Integrating a flat, lightweight, easily replaceable screen that's also software updatable helps simplify both maintenance and future upgrades.